Hello everyone. Today we will learn the another joint, that is a spherical joint. So how to create a spherical joint in mechanism. We are going to see what are the purposes of it and what are the degree of freedom for this spherical joint. So basically this spherical joint you can see in the bike mirrors, you can see that. So now we will see, just again I will just show you an image, that is spherical joint. In this way you can create a spherical joint. So two spheres are in contact with each other. So spherical joint removes all the translational capabilities and merely has a rotational degree of freedom. So it is only having a rotational degree of freedom. Therefore the spherical joint has 3 rotational degree of freedom. So all these rotational degree of freedom are open in spherical joint, and all the translational degree of freedom are locked. So there is no command associated with this joint. So we don't need to provide angle driven or length driven. So here is no command associated with this joint. So now we will see how to create a spherical joint in this mechanism. So just I will again create a part. So let us say first we will create a base part, base spherical. So we will create this by revolving that is by shaft command. So just reverse this and swap this part. So now we will create the circle. So circle, we will create a arc here. Select a center point, select this point and this point. We give the dimension for this, let's say it is 100 mm. Just create this line. Now we will exit this and select a shaft command, select the profile and select the axis. I will select this axis for revolution and click preview. So now I will getting this whole sphere here. So I will provide 180 degree for this, and now see the preview and now click OK. So I want half sphere here, hemisphere. So again I will add a circular, that is a spherical pocket here. So again I will need to groove this here. So just I will again sketch on this top face. Now I will again create a arc here. Just select this edge and then select this edge. Just provide a radius here. Let's say it is 80 mm. Again create a line. Okay, so now again exit the workbench. Now select the groove here. Again select the profile and select the axis. Just select this axis and then click OK. So now our part is ready. Again I will add some other feature here. So before going to add this groove, I will add a feature here. So just right click on this shaft and then define work object, and now I will add one more feature on this face. So just add rectangular. So let's say it is 30 mm. sorry. You can just give a distance here. So again, let's say it is 30 mm. And now exit the workbench, and now I will add the material in the reverse direction. I will add a approximate distance here and then click OK. And now I will select the other defining work object, and then so in this way our part 1, that is the base spherical, is created. So now I will again save this. I will create one more folder here, so that is a spherical joint. And then save this part. Now we will create another part here. So now we will create another part here. So let's start again with the part design. Now we will create the upper part. So let's say your name it is a top spherical, and then click OK. Now we will again create a profile, that is circular profile. Select this center, select this edge, select this edge. Again I will give the dimension to it. So again, let's say I will provide a 80 mm now, and select a line command. Just add a line here, and then exit it. Again with a shaft command, select this profile, and then select the axis, and then click OK. Now we'll create a total sphere. Now again add one more feature here. So let us take a reference plane. Just select this plane and just select angle to the angle or normal to plane. So select the rotation axis. So I will select this rotation axis and select this as a reference, and then sorry, I wrongly selected that. Again select angle normal to plane. So now select a rotation axis, this axis, and then select this reference. Now I will again select this, select angle normal to plane, select this as a rotation axis, and select this reference. And now I will provide an angle to this angle. And now I will create one feature there. So again I will create a rectangle here. Just provide the dimensions. Provide a length. And then exit the workbench. Now similarly again add a material here. Add a approximate. And then click OK. So now our second part is also completed. We will again save this part. Now we will create a assembly of these two parts. So just go to the mechanical design and assembly design. Then call the existing component, click on this product, select this base spherical and open it. Now again I will first fix this part. Just fix click on this part. Again I will call another part, that is a top spherical, then click OK. Now I will first move this part and then click OK. Now I will directly create a contact constraint here. Just select this edge and select this edge and then click OK and then update this. So again this is the constraint is made here. Now we will see the mechanism that go to digital mockup and Dmu Kinematics. Now again I will delete this constraint from the rigid assembly. Just select the fix, create a new mechanism, click OK and then select a fixed part here. So I will fix this part. Now select the spherical joint here. Now you need point 1 and point 2 you have to select here. So here you need to select the sphere joint, that is sphere 1 and sphere 2, the points from this center of the sphere and this sphere you have to select. So again you need to create that points here. So I will directly go to the part. Just I will double click that part. So in the base spherical, just create a point here. So again select the circle sphere, that is center you will get here. Just select the sphere. So select the sphere and then click OK. So you will get this point as a center of it. So again similarly double click on this top spherical part and now again select a point, again select a circle sphere and then select the sphere and then click OK. So again you can see that point in this. Now again go to the product. Now select this joint, that is spherical joint, then select the point 1, let's say select point 1 for the base and then select point 2 and then click OK. Now I will again collapse this. You can see here the mechanism, and in that you can see the spherical joint created. So, but only with this option, only with this mechanism, we cannot simulate that because we have not seen that message that is your mechanism can be simulated. And also you can see from this mechanism that is the 3 degree of freedom are still open there. So we need to constrain this degrees of freedom. So to constrain this, we need to insert another body here. So just go to, so again I will again go to the mechanism and the assembly design, and here I will add a new part here. So insert a part and click on the product, and then again I will keep the same origin, and in this part just double click on this part and I will create simply a line here. So I will first hide this axis system here. So now I will directly create on this face here. Create simply a line here, and then exit this. And take a plane normal to this curve. Just select this curve and select this point here. Okay, so now this is a part only we have this surface extracted, so because we have selected this and this sketch and this plane. Okay, so now again we will go to, just double click on this product first and then go to digital mockup, enter Dmu Kinematics. Now again you need to provide a revolute joint here, so just provide a revolute joint. I will again, so before going to do this, I will first change this part, because here I cannot select axis here, so I will just edit this sketch. So I need to change this. I will keep this as it is. I just change this part here, and again I will go to this pad here, and I create here a circle. So just I will create a circle here and then exit this. Now I will delete this surface here, double click on this part, delete this also. Now I will create once again here, so go to this sketch and I will sketch on this plane here. Go to this, select this line. I will create a line here and create a plane here. Select normal to curve and then select this point and then click OK. Now our geometry is correct now. So again go to product, go to digital mockup, Dmu Kinematics. We are already in that. Okay, now we will provide a revolute joint here. So just select the line, that is we need to constraint, that is we need to reduce the degree of freedom of this part. Just select this line 1, the axis of this cylinder, and then select the axis of this, and then select the plane, that is we will select this plane and then select this plane and then provide an angle driven and then click OK. So now again you can see there are again 3 degrees of freedom remaining. Now we will create another joint here. We will make a rigid joint of this part and this part. Just select this part and select this part and then click OK. Now you can simulate this mechanism, and now you can see that the degree of freedom for this are 0. So in this way, for the spherical mechanism, spherical joint, we need to use the other joints like the revolute joint and the rigid joint. So now you can create a simulation from this. Just simulate, select the mechanism, and now you can rotate this, then insert. So again jump backward and then again change these interpolation steps, and then you can see the result here. So in this way you can create a mechanism for this spherical joint. Again, if you want to save this with a compile simulation, you can generate a animation file here. So again, give a file name here, spherical joint, create a file, and then again select a time step, and then you can create that video file for this spherical joint. Similarly, to save this video file in this tree, just select this generate replay, and then again select the time steps, and then click on OK. So it will be saved in this tree as in the replay. So you can play this later from this replay option in the tree. So please subscribe my channel and like my videos. If you have any queries, comment below. I will definitely try to solve each of them. So thank you for watching.